everybody. Welcome to week 15 for geometry. Today in our lesson, we're going to cover section 7.3. So our learning objective is I can use inequalities to describe the relationship between side lengths and angle measures in a triangle. So we're going to be talking more about those relationships, side lengths and angle measures, including something called the triangle inequality theorem. So that's what we are actually going to start off with. So our essential question then, how can we use inequalities to describe the relationships between side lengths and angle measures in a triangle? All right, so make sure that you are writing this down, and that's going to be our goal for today, is to answer that essential question. All right, let's get started. Okay, so we're going to start with that first theorem that we mentioned, so the triangle inequality theorem. All right, so let's look at the words first. So the sum of any two side lengths in a triangle, so if you pick any two sides and add them together, that has to be greater than the third side length. Okay, so we have an illustration here. This is just showing you all the different combinations. There are three sets of them, right? So adding the two side lengths together has to be greater than the third side. Here is another variation, and here is another variation. So in order for a triangle to be formed, all three of these need to be true. Okay, so that's what this is saying down here. So to be able to form a triangle, each of those three inequalities has to be true. So you have to check all of them in order to say, yes, a triangle can be formed. Okay, so if you're given three side lengths, you can actually test these to determine if they can be used as segments to form a triangle. Okay, to show that three lengths cannot be the side lengths of a triangle, you only need to show that one of those inequalities is false. So if you're setting them up to kind of test to see, if you get it on the first try, if it is not a true statement, you're done. They cannot form a triangle. All right, so we're going to practice a couple examples with this first, and then we're going to talk about some other relationships between the side lengths and angle measures of a triangle. Okay, so our first example, this is very similar to question number 1 on your summative for this week. So we're going to use the triangle inequality theorem to tell whether a triangle can have the sides with the given lengths. So we have three lengths here. We have 4, 8, and 10. So we have to use that inequality theorem, which means if they can form a triangle, all three of those inequalities need to be true. If they can't, then we're looking for one of them to be false. Okay, so let's just set them up and then we'll work through. All right, so our first one, it doesn't matter what order you do these in, we just need every combination. So my first one I'm going to set up is the first two. So that would be 4 plus 8, and that needs to be greater than 10. Okay, let's just set up the other ones here. So our second one, let's do 4 plus 10. That has to be greater than the third side, so greater than 8. And then our third combination would be 8 plus 10. That needs to be greater than 4. Okay, so let's test these. So with the first one, if we add those together, we would get 12 is greater than 10. Well, that is true. Okay, we're looking for the other two to be true if these three lengths can work. All right, so next one we would get 14 is greater than 8. That is also true. Okay, let's do the third one. 8 plus 10, we get 18. That is greater than 4. Yes, that is true. So the answer is yes, right? We can form a triangle. Good. All right, let's try another one. So I have 3 more lengths here. All right, so again, getting us ready for that question number 1. So we're going to use the triangle inequality theorem, just like the last example, to determine if a triangle can have these three side lengths. So we have 7, 9, and 18. So again, let's set them up and then we will test to see if we get true statements. So first combination, I'm just going to go in order here. So we have 7 plus 9, right? That has to be greater than 18. Okay. The second combination, 7 plus 18, that has to be greater than 9. And then our third one would be 9 plus 18. That has to be greater than 7. All right, so let's check the first one. If we add 7, right, plus 9, well, we get 16. Is that greater than 18? That is a false statement. That's not true. So because we have one of the combinations that does not work, we do not have to check the other two. We're done. Because remember, all three have to work in order for a triangle to be formed. So the answer for this is no. Nope, we cannot form a triangle with those three lengths. Good. Okay, so let's move on then to another relationship between side lengths and angle measures. Okay, so still involving our three sides here. So if we are given two side lengths for a triangle, okay, we're given two of them, not a third one. There's actually an infinite number of side lengths available for that third side. Okay, but based on those inequalities, the third side is also restricted to some certain values, and it's determined by that inequality theorem. Okay, so we're going to be using this inequality theorem to kind of limit and find what that third side would have to be between. Okay, so our first example we're actually going to take a look at is already done. So we're going to work through this together, and then we'll do another example that is not complete. Okay, so here is kind of what something like this would look like. Find the range of values for x, right, that third side, using the triangle inequality theorem. So we're going to find possible values for that side length. Now we can use our inequalities to help us. The difference is we don't have one of those side lengths, but we can still set up our three inequalities. So let's go ahead and take a look at those. So I'm going to scoot this down, just double check. Okay, so here is one of them, right? We would have x plus 10, that has to be greater than 12. Okay, our second one, x plus 12 would have to be greater than 10. And then our third one, 10 plus 12 would have to be greater than x. So if we isolate x for all of these, okay, the first one we would subtract 10 over, right? We would get x is greater than 2. The middle one, we would subtract 12 and we would get x is greater than negative 2. We'll talk about that in a second. And then the third one, we would add those two together. So 22 is greater than x. Okay. When you do something like this and you actually get a negative number, okay, we can't have negative side lengths. So this one is not going to be part of our range. But these two are. Okay, this is going to help us isolate x. So let's kind of talk through what this is saying. The first one is saying that x has to be greater than 2. Okay, so 2 would be our minimum to start, right? And it has to be greater than that. This third one is saying that x has to be less than 22. So that would kind of be that max, and x would be blocked in between. So we want to put that together in one compound inequality. So that would look like this right here. So 2 is less than x, which is less than 22. That gives you the range for the possible x values of that third side in order for that triangle to be formed. Okay, this written down here, this is just kind of a reminder of what we already talked about. If you do have that negative side length, you can ignore that piece. That is not going to affect your range. Okay, so let's try another one. Okay, our next example is not going to have the work filled in, so we'll work through it together. Okay, so getting you guys ready for question 3 and 4. So we have a triangle here. Notice two of those side lengths are actually equivalent. This would be my isosceles triangle, right, from last week. So we're going to find the range of values for x using that triangle inequality theorem. So let's set up our inequalities. All right, then we'll work through it and then work to combine to get that range. All right, so our first one, again, doesn't matter what order we do this, we would have x plus 15 has to be greater than 15. There's one. Now, two of these are going to be the same. Just going to set it up just for illustrative purposes, right? Because two of the side lengths are the same. So our next one would also be x plus 15 is greater than 15, right? Those are both going to generate the same inequality, okay? So then our third one would be 15 plus 15 has to be greater than x. Okay, so let's isolate x and we'll get kind of our bounds here. So our first one, we would go ahead and subtract 15 from both sides. So we end up getting x is greater than 0. Our second one is going to give us the same thing. So we don't need to solve that, right? We're not going to get a negative there, so it doesn't matter. Our next one, we can combine our 15s. So that is saying 30 is greater than x, right? So x has to be less than 30. And then this one is saying x has to be greater than 0. So let's turn that into a compound inequality. So that would look like 0 is less than x is less than 30. So x has to be within that range in order to form a triangle. Good. Okay, we're going to move on to a couple other relationships here with our side lengths and angle measures. Okay, so working with our side and angle relationships, that's where we're headed next. All right, let's take a look here. So our first piece, if two sides of a triangle are not congruent, okay, then the larger angle is opposite the longer side. Okay, they're across from each other. And that also means then the smallest angle is opposite the smallest side, and then the middle is opposite the middle side. Okay, so it has that relationship. So there is an illustration here. This is not all the different pairs. This is just illustrating one set here. So if AC, okay, is greater than BC, so if that side length is greater than the other side length, then angle B, which is opposite angle AC, has to be bigger than the measure of angle A, which is opposite that smaller side. Okay, so there's that relationship there. So let's kind of use this. The goal is to kind of put our angle measures in order. All right, so let's try a couple examples. Okay, so we're going to do a couple examples here using what we just talked about. Okay, so this is related to question number 2 on that summative. So for each triangle, order its angle measures from least to greatest. So what we have to do here, we have this kind of set up for us. If we identify the longest side and the shortest side, right, we can identify the greatest angle and the smallest angle, and then the middle one just goes in between. Okay, so the longest side length, right? So let's label that. Our longest side length here, if you take a look, right, it would be this one with the 15. So that would be our AC, okay? So the greatest angle measure then would be opposite that. So opposite is across. So that means the greatest angle measure would be the measure of angle B. Okay, so there's that first piece. So now let's do our shortest. So shortest side, right, that would be right over here, 10. So that is our AB, which means the smallest angle measure would be across from it. So that would be our angle C. Okay, and then our middle again would be our 12 and our angle A. So let's order these then from smallest, least here, to greatest. Again, we're doing the angle measures. So that would mean, right, the measure of angle C would be the smallest, angle A would be that middle, and then angle B would be the biggest. So ordering those using what we know about the relationship between side lengths and angle measures. Good, let's try another one. So I have this here. Okay, so same sort of thing, just a different illustration. Notice we have different side lengths but closer together. So 20, 21, 22. So let's kind of do the same thing here. Okay, we still want to do our least to greatest. So longest side length between these two, right? That would be our 22. So that would be our CB or BC, which means the greatest angle would be opposite, right? That would be angle A. So let's do shortest side length. Shortest side length would be our 20, which would be our AB there. So then the smallest angle measure would be opposite of our 20. So that would be angle C. Okay, so now let's order all 3 of them. Again, that middle one would be angle B, right? So our order least to greatest, right here. We have angle C first, angle B, and then angle A. Good. All right, let's take a look at a few more here. Again, you should kind of hopefully see that pattern. So again, we're ordering least to greatest. So take a look at our side lengths, take a look at your labels for your angles, and let's put them in order. Opposite those side lengths. So this one here, and you can pause it if you want and then write them down. And then I'm going to move them. So here would be the correct order. It would be angle A, right? That would be the smallest because it's opposite our 15. Angle B, and then angle C. Good. All right, next one here. Smallest would be the measure of angle B, right across from our 7, our smallest side length. Then it would be C, and then it would be our A. Okay, good. So our final piece is kind of the opposite of what we just talked about, our angle side relationship. So hopefully kind of you were seeing that. So let's move this. So if two angles of a triangle are not congruent, the longer side is opposite the larger angle. So it's just kind of reversing what we just talked about. So instead of giving you side lengths, right, and having you order the angles, if you have the angles, can you order the side lengths, right? So it's kind of opposite of what we just talked about. Okay. So notice we have 3 angle measures here. So we can use this piece up in our box to help us. Okay. So let's go ahead and read through this. So for each triangle, we have one here, order the lengths from least to greatest. So opposite kind of what we did, we're going to identify the greatest angle measure and then the least angle measure, right? And therefore, the opposite of that would be the longest side length and shortest side length, and then we can put all 3 in order. Okay, so let's go ahead and do our greatest angle measure first. So if you take a look here, again, notice 70 would be the biggest. So our greatest angle measure would be the measure of angle A. So then the longest side would be opposite that angle measure. Okay, so CB or BC. Remember, it doesn't matter your order there. Okay, so our least angle measure would be right up here, 45. So the measure of angle C. So then the smallest side length would be opposite of that. So AB. So now let's order our side lengths, least to greatest. And here you go. So we would have AB first, then we'd have AC, that middle side length, and then BC, because that is the longest. Great. All right, a couple more here, and just practicing that. If it helps to kind of write those out like we did with the last one, that's okay, but hopefully you're kind of, again, seeing that pattern. So we want to do this least to greatest. So smallest side length to greatest side length. So take a look at our angles here, right? The measure of angle A would be smallest, angle B, and then angle C. So we're looking for the sides opposite of those. So our order for this one would be CB, AC, and then AB. Good. Take a look here. Notice we have that 90-degree symbol. We have a right angle. We have 30 and 60. So again, smallest here would be our 30. So opposite that. And then our 60 and then our 90. So here is our appropriate order. AC, BC, and then AB. Good. All right, guys. So that is it in terms of examples. A couple reminders then as we are heading into the rest of our week 15. So make sure that you are attending one of our live sessions. It's going to help you get ready for that summative. If you need some extra practice, remember you do have a worksheet and some book problems that you can complete as well. And then when you are ready, you can go ahead and take this week's summative. Good. If you have any questions, please make sure that you are reaching out. And I hope you have a great week.